Hi everyone. So in part 2, episode 3 of our Tyflow Voronoi fracture, we will create an animation using this same method. So I'm just going to add a little bit more detail to this object. So I've added a bend to this cylinder, and then you can see there the degree and angle you can provide to the bend. So you can either curl it a bit more, make it almost like a ring, and you can see there as you adjust the angle, the ring will either tighten up or it'll stretch out depending on that degree that you provide the bend. So I'm just going to leave it at 180, just the way I had it. Sweet. So the next modifier I used was the greeble modifier. So what it essentially does is subdivide the surface that you have and creates random extrusions at given heights that you generate there in the panels tab. So for instance, if I give a minimum height of 5, max height of 8, this is obviously the units that you have set up in your file. And there you've got widgets. So your widgets tab there, you'll adjust the kind of size, maximum size. So what it will do is just create a random array of widgets just to apply an even more articulated geometry. So if I go ahead and show that geometry, you can see there the random extrusions with those little widgets on the end bits of them. So you can see that detail in there, that it's subdivided and extruded those points. All right, so I'm just going to go ahead and just put those values back to the values I already had ready. Okay, so my values now are minimum height of 1, max height of 10. So that's just to create a little bit more of a distribution, a bit more random. So here on my layers tab, you can see that I have my Tyflows hidden just to kind of keep them out of the way. So if I turn my Tyflow on, which is the Tyflow I prepared in part 1, and I hide the cylinder, so now we can only see the Tyflow of this object. So this is the object that will simulate. And if I fast forward the slider, you can see that explosion. You can see it's a much larger explosion because you have far more particles. And if I press play and tab through each viewport, you can see that simulation happening in each view. So what we want to do with this is obviously create an animation for this. So we'll go to our camera view, hit play again, and then we can see how it's going to look in that rendered view. So have a bit of a play with this, find your kind of happy medium and the frame that you want to show. So I'm just going to adjust the camera there. You can see that I can move the camera around slightly just to get a bit more of the explosion in focus and in frame. So yeah, just pivoting the camera around based on that target point, just so we can see a bit more of the object as it falls. Okay, I think I'm happy with this one. So now that we're in our camera view, we're going to go to rendering, render setup. Now the main thing we're going to adjust, as opposed to doing a single render, we're going to use an active time segment. So this will essentially render views based on what you've created down here in your frames. So in our instance, we have 60 frames. So we can choose the range either 0 to 60, or we can specify a bit more of a more focused range if we don't need to render the start of it that doesn't show the object at all. Then I'm just going to keep my other settings the same. I generally like to do a test render just to see how it will look. So this is just showing the render from part 1 that I had done. So slows down a little bit more as there are more particles to show, so the renders slow down a lot more on my computer. But if you have a faster processor, you'll be able to see that. So the next important thing to check is the save file. So what you want to do is create a file path or a destination where you'll create your rendered keyframes. So you can see there, the folder that I've created, it'll name each slide based on its frame. So this helps for when you want to then merge the file to create the simulation. Thanks, and I hope you enjoyed my two-part series on Voronoi fractures. Thanks.